We need to consider the bend adjustment value and length increased by hook. Of course, we also have straight length, diagonal length. This is the cutting degree of the bent-up reinforcement. That is the cutting length of the bent-up reinforcement. You can't follow the dimensions in the drawing directly. We must calculate according to this formula, in which bend adjustment value is a key. Let's take a look together. What is the bend adjustment value? When we measure the rebar, what we measured is its outer dimension. But the actual rebar is like this. The length of its central line. If you used to run, or if you calculated the perimeter of a circle and the perimeter of a square before, for the same radius, we know that this length will be longer than the length of the bending semicircle. That is, the actual length will be shorter than the length we measured, right? That is, for our bend adjustment value. It's actually the outer dimension, which is the difference between the length measured at the outer length and our center point, i.e., the center line of the rebar. Every time we calculate the cutting length of the rebar, we must subtract the rebar adjustment value. Bend adjustment value for the rebar. For the bend adjustment value of the rebar, like bending 190 degrees, no, bends 90 degrees. So how much do we need to adjust? I just subtract the outer length from the length of the center and get the difference. Length of a quarter circle and our outer length. Here is the calculation method. This is a 1/4 perimeter. The diameter of the rebar, the 1/4 diameter of the rebar, plus this, the diameter of the rebar plus the diameter of the bend. 1/4 pi because it is 1/4 of a circle. The perimeter of the circle is 2 pi r. And then subtract. Subtract to c. CB. We should calculate in this way. Of course, the bend diameter of rebar depends on its size. Usually we will use 2.5 times the diameter, or 4 times the diameter of the rebar. After calculating these two values, if the bend diameter is 2.5 times the diameter of the rebar, it will probably save rebar length. That is the actual cutting length of the rebar. The length we measured will be 1.75 times less than the rebar diameter. If the bend diameter is 4d, the length saved is 2.07d. We must consider this. We take the approximate value 2d for these two lengths. That is to say, the error is within the permissible scope. But we must round up. After considering this is allowed. This is our bend adjustment value. When you bend 90 degrees, we use the adjustment value of 2d. There is also a length increased by hook. Length increased by hook. What is the main purpose of the hook? We just showed it here. Let's ask a classmate to answer this question. What is the function of the rebar hook? The function of hook. Do any classmates know the answer to this? The function of hook. We will ask this classmate to answer the question. The length of the hook of the rebar. What is the length of the hook used for? Why do we use a hook?
Increase friction. Increase anchoring.
Right? Very good. Sit down. In fact, the hook is just like our human hand. When we're pouring reinforced concrete, which were originally two unrelated things, we need to make it an integral part. The rebar is easy to pull out of the concrete, especially when they are under tensile forces, right? So we need to increase the degree of anchoring inside the reinforced concrete. Anchoring. Increase its anchoring. We have taken a lot of measures for the rebars. For example, the surface of the rebar is treated to be thermally conductive. Also, we use a hook to prevent it from sliding. Especially the plain round bars, stressed plain round bars. We must make a hook. The stressed plain round bars. The length increased by hook. This is a semicircle, not a quarter circle, plus the length of the straight segment. The length of the straight segment is 3D or 5D. Let's calculate by 3D. So its actual length is like this. And the length we measured is here. You will need this length. This length equals the semicircle plus this, equal to the distance from this point to this point, and subtract this point. It's the length we've increased. When we measure the length, we will measure its outer length and measure up to this point. And as its length increased, we can get 6.25 by the same method. For the increase in length made by the hook, let's give an example of 180 degrees. We bend the rebar. The bend angle of the rebar is 90 degrees. In fact, due to the actual situation of the member, we will use different angles. For example, if the member is high, we can use bend angle, 135 degrees. If the member is low, we will use a small bend angle. Like the hook here, the angle for the hook, normally it is 180 degrees. Sometimes we will bend at a 90-degree angle. 90, bend 90 degrees and pull it up directly. Pull it up. Sometimes we will bend an angle of 130 degrees to make. It's easier to pour concrete into the member. This is up to the actual situation. No matter what bend angle, there is no need to calculate like we just did. We just need to know the calculation principle. We can say in this way, just understand its concept and their differences. These are the two key points of the bent-up reinforcement. Bend adjustment value and length increased by hook. Straight length and diagonal length, especially the straight length, we just measure the length in the drawing directly. We can use these two adjustment values to calculate the cutting length of the bent-up reinforcement. Okay, we have talked so much. Let's practice together. We use the reinforced concrete member just mentioned. We already know its shape. Let's calculate the cutting length of the number 3 rebar. Let's start now.
It is like this. Then unite with your cadres to discuss the relevant matters. We have now calculated 3 sections of the project. Investment in construction. Not enough emphasis.
You can discuss it with each other.
This is not important. And then followed by the late stage. First, calculate the results obtained by the cadres and the finance department. This company has built 240 plus an additional 10. Who else will go to follow up first? There is no problem with budgeting and accounting.
I posted it on the learning platform. Please delivered once finished.
I am now checking several accountants for bidding. Please go again. Who knows they completed such a sign? Add that segment is just entering or at night. Because there was none yesterday. Multiply by 20,000. It is generated by us in the computational model. The length of some of the lower products of the steel reinforcement here. Subtract 2 protective layers. Subtract the protection. And then subtract 1 factory at a time.
Already finished? Upload once finished.
The time period of the upper part. It is equal to its 241 diagonal. Add the upload after finishing. Which protective layer is it? This kind of thing completely overwhelms me. Add the angles of these angles. Go to the main road on the medium to long route. So it's equal to 34,000 in projection. Yes, there are 2 times when the 2 highs are still present. Bank quotes with high levels. The data flow is moving upward. Adding the image at the back will be enough. And then divide it into 3 stages for a long time. Other bends increase the waist. This is 1 meter long, size 2. The square root of 2 is the Pythagorean theorem. 50,000 and 10 million of even earning money. Then protective wall. Continue to protect the contractor just now 7. Based on the subtraction of 2,816 to develop a long-term protection score. Good afternoon here.
Some classmates have finished. Of course, the answer may not correct. Okay, let's take a look together. What are the issues with this answer? Okay, the straight length on the top. Straight length on the top is 240 plus 50 plus 500 minus. Minus what? Be sure to minus the protective layer. Of course, there are two sides multiplied by 2 equal 1,350. Second, the horizontal projection length of the slant bent-up segment. The horizontal projection of bent-up segment. Is the horizontal projection equal to the vertical projection? They are the same. Why?
Because it is an isosceles right triangle.
The equivalent value is 3,000. So the value. Horizontal, this digital projection. Its digital projection is equal to, its height is 500. Minus what? Minus 2.
Thin layer.
Be sure to minus this. Minus what?
The diameter of the stirrup.
That is, the stressed steel bar on top of the bent-up reinforcement. It has stirrup, although we cannot see it from the elevation drawing. Can you see it in here? Yes. What is this? What are these 2 points? What are these 2 points? The 2 points in the center, number 3 rebar. Number 4 rebar is what? Rebar? Bent-up reinforcement. What is on top of the bent-up reinforcement? Stirrup. So for the height of the stirrup, what else is there besides protective layer? The diameter of the stirrup. Do many classmates make mistakes in their calculations? This classmate also made a mistake as expected. He didn't subtract the diameter of 2 stirrup.